Part 1. The wood that should have changed everything. There is a kind of wood that can outlast concrete. Fence posts driven into the ground in the 1800s are still standing today, solid and sound, while modern treated lumber often begins to fail in a fraction of that time. No chemical coating, no industrial treatment, no constant maintenance. Just a tree whose natural strength seems to defy everything the modern building market tells us to expect. And somehow, as it grows, it does something even more remarkable. It helps bring dead soil back to life. For centuries, this wood helped build America. It was not discarded because it was weak. It was pushed aside because it was too effective. A material that can last for generations is hard to turn into a business built on replacement. A tree that restores the land threatens industries that profit from exhausted soil. A wood that needs no poison leaves little room for chemical dependence. This is the story of black locust, the nearly forgotten timber that endured too well to remain convenient. Part 2. The discovery that should have made it legendary. The story opens in Jamestown, Virginia in 1607. English colonists were racing against time, desperate to raise shelter before winter closed in around them. They planted 4 wooden posts into the earth, one at each corner, and built their structure around them. At that moment, the choice of wood was not a matter of convenience. It was a matter of survival. A century later, in 1707, naturalist Mark Catesby visited the remains of that settlement and found something that must have seemed almost impossible. Those original posts were still there, still sound, still holding their form as if time had somehow passed around them instead of through them. After 100 years of rain, insects, shifting soil, and constant exposure, the wood showed no meaningful decay above ground or below it. It looked, in his words, as though it had only recently been placed there. That wood was black locust. Long before colonists recognized its value, indigenous peoples already knew exactly what kind of material it was. The Cherokee and the Iroquois used black locust for bows because few other woods could match its strength. They used it for tool handles built to endure years of hard labor, sometimes long enough to outlast the people who first held them. This was not ordinary timber. It was a wood with a reputation for refusing to die, a material whose durability was so unusual that it entered memory not just as a resource, but as something almost stubbornly alive. Part 3. The wood that helped decide a war. By the time the War of 1812 arrived, black locust was no longer just a remarkable building material. It had become a strategic advantage. American shipbuilders were facing the British Navy, the strongest naval force on Earth, and the difference between survival and destruction often came down to what held a ship together. British warships relied heavily on oak pins and fastenings. American builders used black locust tree nails, dense wooden pegs so hard and so reliable that they created joints tighter than metal once they absorbed water and swelled into place. When cannon fire struck, that difference mattered. British ships were more likely to split apart as planks loosened and structure failed. American ships held together with far greater resilience under punishment. In a war fought at sea, black locust was not just wood. It was an edge. The British eventually understood what they were up against. By 1820, Philadelphia was exporting tens of thousands of black locust nails to England every year, somewhere between 50,000 and 100,000 annually. The same empire that had fought against American ships now wanted the wood that had helped make those ships stronger. That reversal says everything. Black locust did not earn its reputation through myth. It proved itself under pressure, in the most unforgiving conditions imaginable. And that raises an even bigger question. If a wood this strong once helped reshape naval power itself, how could a material like that nearly vanish from everyday American life? Part 4. The tree that did more than endure. Black locust was extraordinary, not only because it lasted, but because it combined durability with functions that seem almost too useful to belong in one tree. Its hardness reached about 1,500 pounds on the Yonka scale, stronger than white oak. Its crushing strength was around 10,200 pounds per square inch, putting it in a range comparable to concrete in raw compressive resistance. It also carried its own built-in defense system. A natural compound called rhobanin helped protect the wood against fungi and insects without the need for chemical treatment. That is why tests cited by the U.S. Forest Service found that black locust could take about a century to rot even when buried in soil. Fence posts from the 1920s were still standing. Telegraph poles from the 1870s remained in place in the American West. In Hawaii, black locust pilings used for the Ford Island Bridge in the 1910s were still in service after a century in saltwater, one of the harshest environments any wood can face. But even that is only half the story. Black locust did not just resist decay, it improved the land around it. As one of the few nitrogen-fixing hardwoods, it formed a partnership with root bacteria that pulled nitrogen from the air and turned it into usable nutrients in the soil. Studies described in the source show that soils around black locust contain far more nitrogen than nearby land, with the tree fixing roughly 75 to 150 kilograms per hectare each year. In other words, it was producing timber while also feeding the ground. When millions of acres of black locust were cleared for cattle in the late 19th century, the damage appeared fast. Soil cracked, rivers dried, grass weakened, and livestock suffered. By the 1970s, ecologists had begun classifying black locust as a keystone species for soil stability and land recovery. So now the mystery becomes even harder to ignore. If this tree was strong, long-lasting, and capable of healing depleted land, why did the modern system stop centering it? Part 5. When permanence became a problem. The turning point begins in 1933 when Indian chemist Santi Kamasam developed chromated copper arsenate, or CCA, a chemical treatment that could make cheap softwood last longer. By the 1940s, CCA-treated lumber had begun to dominate the American market. It offered the industry something black locust never could, a product that looked durable, sounded modern, and still guaranteed future replacement. Black locust lasted too long to fit that model. A farmer who bought black locust fence posts in 1950 might not need new ones until 2050. That meant decades without another sale. Treated pine, by contrast, often failed within 15 to 20 years, which kept customers coming back. The logic was brutally simple. In a market built on repeat demand, planned obsolescence was more profitable than permanence. By the 1990s, the darker side of that system had become harder to ignore. Studies found that CCA-treated wood could leach arsenic into surrounding soil and water. Children who played on treated structures in warm climates were shown to face a cancer risk high enough to draw federal concern. On December 31, 2003, CCA was banned for residential use. But the underlying business model did not disappear with it. The industry simply moved on to newer treatments such as alkaline copper quaternary and copper azole. The chemicals changed, but the structure of the market stayed the same. Treated lumber still decayed faster than black locust. It still introduced industrial compounds into the environment, and it still ensured that customers would need to buy again within a generation. So was the real problem ever about performance at all? Or was black locust pushed aside because it threatened a system that depends on things wearing out? Part 6. The wood was never lost, only removed from the market. Black locust faced one more obstacle, and it was a practical one. It did not fit cleanly into industrial processing. The trees often grew crooked as they competed for light, which created tension wood that could warp after sawing. A native beetle, the locust borer, tunneled through trunks and made milling even more difficult. To sawyers used to straight pine and standardized supply chains, black locust was inconvenient. Large distributors did not want to stock it. Lumber yards did not carry it because customers rarely asked for it. Customers never asked because most had never heard of it. Contractors kept defaulting to pressure-treated pine because it was available everywhere, from big box stores to local yards. The disappearance became self-reinforcing. Black locust did not vanish because it failed. It vanished because the system was built around easier materials that could be sold again and again. Elsewhere, the story turned out differently. In Hungary, black locust spread across roughly 1 million acres and became deeply integrated into practical life. Farmers used it for fence posts, firewood, honey production, and lumber. In Europe, architects specified it for decking, bridges, and urban green spaces. In 2013, the Brooklyn Botanic Garden even used black locust decking in a project that won an AIA Design Award. Yet in the country where the tree is native, It remained a niche material sold mostly by small mills. That contrast reveals the real issue. The market was not limited by demand. It was limited by awareness and supply. People would use black locust if they knew it existed and could buy it easily. But the larger system had no incentive to teach them, and that may matter more in the future than it did in the past. Black locust survives in poor soil, handles cold, reaches deep for water, and produces useful timber without synthetic fertilizer or irrigation. It regrows aggressively, resists eradication, and thrives under conditions that break more fragile systems. In an age of drought, flooding, heat, and instability, those are not minor traits. They are the qualities of a tree built for a harsher century. Farmers can plant it on marginal land and harvest durable posts in about 10 years. Homesteaders can set those posts and forget about them for decades. Permaculture growers can use it as a nurse tree that feeds nearby plantings while producing valuable wood at the same time. The knowledge was never truly gone. It was simply pushed out of circulation. We did not lose black locust. We just stopped selling it, and in doing so, we stopped recognizing what had been in front of us all along. A material of rare strength, growing quietly in the dirt, asking for almost nothing, and giving back far more than the market knew how to value.